Hello and welcome to another episode of The Defenders on Sansad TV. And in this episode, we are discussing a subject which very few people, including myself, have enough clarity on. But it's a very important subject because it's a game changer in the field of national defense and security of any country. And as some of you would know, recently, India once again tested a hypersonic vehicle and it tested the technology that goes behind these vehicles. But I must also admit, in all honesty, we are not quite there. We have been testing, we've been testing in phases, and we are doing a catch-up game with countries like China and the United States. Never mind the fact that we are the fourth country in the world to have acquired this technology, and it is going to have a great influence on our country's both offensive and defense capabilities. And we have two distinguished guests with us. We have Lieutenant General V.K. Saxena, who's a distinguished fellow at the VIF. He's also a distinguished academic and a fellow associated with Center for Land Warfare Studies, CLAWS, and has been formerly the Director General of the air defense arm of the Indian Army. So a man who understands both academically and implementably what can be done. And we have Dr. Sudhir Mishra, former Director General of the DRDO and also formerly head of the BrahMos missile program. So I'll start with you, Dr. Mishra, sir.
Please.
BrahMos missile seems to be one of the platforms that is being considered in the next phase of being given a push by this kind of technology. From what I understand, that this cruise vehicle or the cruise missile that we are looking at inventing, there are lots of academic technology related titles that are being associated with each platform. But the bottom line is that we tested it to achieve the desired flight path. We are not quite there. Why are we not quite there? Because we as a country have also exhibited world-class ability to produce missile technology, cruise missiles like BrahMos missiles being a case in point. So how is it very different, this hypersonic platform, as compared to what we have already produced?
Thank you, Maroof. BrahMos is a supersonic missile, and it's a natural progression to have a hypersonic missile. We have undertaken in DRDO several lead-in projects. So the missile test under HSTDV program, which has been undertaken by DRDO, and we have conducted these tests for three times. So these are the programs which have developed the lead-in technologies. And these leading technologies will result into the development of hypersonic missile program. You see, there are several challenges. The first is we have to carry out the experiments with the booster, then separation technologies, and finally the scramjet engine. The second is we have to develop the necessary materials, fuels, harnessings, plus the engine, which itself is a great technology in itself. It's a cooled scramjet engine. And apart from this, we have to develop a technology called for flame retainer. So these technologies takes a lot of time. And in the test of HSTDV, we have tested few of these technologies. The second is we have also conducted several tests using CFD, computational fluid dynamics. Then we have also developed a supersonic wind tunnel test facility at Hyderabad. And these all were supported by academic research at ISC Bangalore and IIT. So the combined efforts of these all have come together, and we would be able to develop a hypersonic program. Of course, these technologies have been developed at the lab level. Some have been tested, but we would be needing funds to come out with a real product.
That's very well brought out, sir. And you've touched on a point which I'm going to ask you later, that what is the state of funding? But more of that later. And now to the distinguished General. General, sir, it is said that hypersonic weapons are not only disruptive technologies, but they are also possible to be carrying nuclear warheads. Now, the question that immediately comes to my mind, nuclear warheads have been around for at least since 1945, but there has been a lot of debate about their deliveries, and they're not considered to be launched despite threats once in a while. But the fact of the matter is that aren't the delivery technologies for nuclear weapons already adequate? So why is it that this is being considered in the strategic space of nuclear weapons? Could it serve a better purpose for conventional usage, as Russia recently demonstrated in Ukraine?
You use the word disruptive technology. I will start from there. Hypersonic weapons today, why is a buzzword today, is for certain reasons which are the combat virtues or the signatures of the system. Let us just start with one sentence. What is this hypersonic all about? A hypersonic weapon is a projectile, is a weapon which flies greater than Mach 5, which is 1.715 km per second or 6174 km per hour. That is the speed. Second is, it remains in the endo-atmospheric region, means it uses the atmosphere's oxygen to drive its engine. Just keep these two words aside. That with this, what is so special about this? Even if it is doing this speed, by doing this speed, it achieves the characteristic of being unstoppable. Why unstoppable? A hypersonic weapon in the region of 5 to 6 Mach can strike anywhere in the world in 1 hour. Any conventional air defense or anti-missile system requires certain finite time to detect the target, to lock on it, to fire, to destroy. Now, this hypersonic weapon coming at this speed beats that cycle, and that is why it is called unstoppable by any conventional air defense system. One. Number two, more important. With this sort of a speed, the kinetic catastrophic kill capability of such a weapon is extremely huge.
Okay.
I mean, about 36 times the conventional weapon. And third virtue is unpredictability. A weapon being hurled at me at 6, 7 to 10 Mach, it can be maneuvered to any target in my entire defended zone. It is keeping me at a stake for a large swath of area. That is the reason which is the current buzzword: hypersonic, unstoppability, unpredictability, and catastrophic kill capability.
Very comprehensively brought out, sir. This is an answer made for television. May I go back to Dr. Sudhir, sir? Now, you mentioned somewhere about wind tunnels and wind tunnels required for testing. You also referred to that there has been a requirement for funding for enhancing our capabilities. Now, today, everything is being compared with China, at least in our context, and even in the context of the US. That is geopolitically the disruptor today in the world. It has enhanced its capabilities manyfold. And my figures tell me that they have pumped in a lot of money in China, and increasingly so from 2015 onwards. Right? And I think that is when your product, BrahMos missile, also came into reckoning, 2015 to 18, that about time. Now, how is it that this matter was allowed not to be addressed that seriously? Were we going about development in phases? Were we having a shortfall of budget? Were we having an approach which worried me about our strategic thinking, that we had a defensive defense approach, not an offensive defense approach? Your view?
It is apt to say that we have never, I should say that we were not serious. No, we have been all the time serious.
Okay.
And we have been developing the technologies under the HSTDV program. We have invested a lot of money, huge amount of money to design, develop and realize hypersonic wind tunnel. Incidentally, India is third country in the world to have a supersonic, it's not only supersonic, it's a hypersonic wind tunnel test facility. Apart from this, we have spent huge amount of money in the academics. And when it comes to China, China basically has developed a hypersonic glide vehicle. This glide vehicle has been put on a continental missile booster and then launch. So the function of glide vehicle and a hypersonic missile, both are different. The glide vehicle basically is used for strategic reasons, and a missile, hypersonic missile, although we used to call it a BrahMos 2, and that uses a scramjet engine. This scramjet engine is a supersonic combustion engine. You see, we have to understand that in the BrahMos, we use a supersonic engine. This supersonic engine, the combustion takes place in the subsonic region. Everything is known about it. But in the supersonic scramjet engine, we carry out the combustion at a supersonic speed.
Okay, now I just want to interrupt. It has been, I've been informed by some more knowledgeable people that this could be seen as an aircraft also, as a remotely piloted or non-piloted aircraft, which moving at the speed, as the general has brought out, of 5 to 6 Mach, which is what our testing platforms are also registering that speed, is phenomenal speed. Nobody can really pick it up in time to stop its flight path, stop it in its flight path. So what is it that we need to understand? Is this a missile or is it an aircraft?
It's a very interesting question. The answer is also very interesting. The answer is any cruise missile is an aircraft. It's an unmanned aircraft.
Right.
So whether it's a subsonic or supersonic or a hypersonic, it is an aircraft, unmanned, filled with fuel to reach to the destination and a warhead to cause the destruction. And a hypersonic missile flies at, as mentioned by General Saxena, that more than 5, more than 10, more than 15. In fact, the Kinzhal, the Russian missile, it flies more than 15 Mach. And there are many researchers who are talking about a hypersonic missile which will fly at the speed of 20 Mach, 20 times speed of the sound, huge. So that possibility is always there. So the approach of China, India, Russia, US, they are all very different. Chinese are talking about a glide vehicle to acquire the capability to take on carrier strike.
I'm coming to that. I'll come to that. That's going to be my next question.
So let me again give back a reply, which the question which went unanswered. Government of India has funded enough to carry out the basic research, and now to realize the product, again the government would be making a fund. So there is no dearth or shortage of the funds. There were requirement of confidence, a technology capability, which DRDO and BrahMos have achieved. And I'm sure we would undertake a program which will deliver a missile. I think it should take between 4 to 6 years to deliver the product.
Okay, that's reassuring, though I don't know if the enemy is going to wait for you for 4 to 6 years. But Jan Saab, it is said that this platform puts the defender at a disadvantage. You have been head of the air defense arm, so you would understand the disadvantages that accrue from platforms like this. Because the very high speed with which it moves, it makes it hard to intercept or detect. Now, simultaneously, we keep talking about China. Dr. Mishra is also referring to China. And China seems to be in some areas ahead of even the US in some capabilities, like the experimental processes they adopt, like wind tunnel, etc. So, where do we place our ability to defend our space? Forget about attacking, because we have always had a non-aggressive approach. We are more centered around defending our sovereignty. Your view, sir?
Your question has two verticals. Firstly, why it is so difficult for an air defender to take on a hypersonic weapon? That is your first question, which I like to answer. An air defense cycle has 3 steps: detect, intercept, destroy. Now, for a vehicle which is traveling at 5 to 10 Mach and even more, as I earlier brought out, the time available for a conventional anti-missile system to carry out its conventional steps of detecting, identifying, designating the target to a missile system, missile being launched, being guided and destroyed, is simply not there, not possible. Therefore, the weapon is called unstoppable. But is that weapon really unstoppable? Air defenders do not continuously keep on harping on only non-possibilities. We are looking at possibility. What is the possibility to detect an hypersonic weapon? It is called a global look-see capability. What is a global look-see capability? A capability which can detect a hypersonic weapon from the time it is launched in a few fleeting moments. That means the satellite-based surveillance combined with the air, ground and sea-based surveillance in one loop, where you achieve a global sea capability.
Just an interruption here,
Yes.
sir. Do you feel confident, not us, but America and China are the countries that have the maximum number of satellites?
Yes.
Do you feel our good friend America, as it is increasingly becoming known, can provide you the strategic and satellite-based alert? Because there are some blank areas where strategic and satellite coverage does not reach.
I agree. At the same time, we have to see two things. Where is the threat going to mature and what time frame? In what time frame our capability of strategic surveillance or satellite-based surveillance is going to grow? The two are moving on two parallel but convergent paths. ISRO, I do not want to go into that big thing, but I want to say that today and in coming tomorrow, we will be able to achieve the global look-see capability in the targeted areas in the time frame in which the Chinese threat will mature.
And in our region.
Yes,
in our region.
yes. And also, let me just clarify one small point. China does not only have a hypersonic glide vehicle, it has both hypersonic glide vehicle, hypersonic cruise vehicle, but still in the testing phase. It has tested in May 2018 a hypersonic glide vehicle, whereas in September 2020 it has tested a hypersonic cruise missile called Starry Sky 2. That's okay. We are also, as a proud Indian, let me just take you through four or five steps. Our journey has not started today, sir. Our journey for hypersonic started in 2004 when DRDO first took up the design for a hypersonic weapon. In 2008, we were thinking of dual use technology between a satellite launch vehicle and a hypersonic vehicle. Between 2011 and 16, we imported 2 wind tunnels, one from IAI of Israel, another from made possible by National Aeronautics Laboratory. In 2019, 12th June 2019, we launched our first hypersonic technology demonstration vehicle you mentioned. It failed. Why it failed? It failed because the booster which was used was Agni 1. At a point in time, the booster became uncontrolled. Though the vehicle did 6.5, it flew to an altitude of 32 kilometers and it did 16.7 seconds. But the test was considered failed. 12th June 19.
Right.
Thereafter, what happened? Thereafter, in 2020, September 2020, we launched another vehicle. This time, the booster behaved a little better, but not as bad as little better. On 27th January 2023, we have launched another same hypersonic vehicle, Agni 1 booster. This time, the vehicle flew for more than 22 seconds. Though the DRDO, their official statement has not come out on success and failure, but we have achieved. Now, there are 7 different hurdles. You talked about a hurdle. It is not simple. Thermal shield, 22,000 degree, 2200 degrees Celsius, 4000 degree for the temperature, sir.
Dr. Mishra Saab, you mentioned about China. You mentioned about our capability for using this in the high seas also. there is this whole India-China rivalry which is coming out of US-China rivalry in the Pacific region. And the Chinese are looking at hypersonic weapons to strike military targets even on US mainland bases like Guam in the Pacific. So where is it that the Americans are falling short of China's determined drive to challenge America's dominance of the high seas or the Asian strategic space, if I might call it?
You see, Americans have already taken action to take care of hypersonic missiles of China. They are investing hugely in high energy weapons. So this is the only weapon which can destroy an incoming hypersonic missile. And they are working on several high power microwave as well as high power laser systems. So that is the ultimate defense against hypersonic missiles. This is number one. Number two, they are also developing the hypersonic missiles of much higher Mach to match the Chinese capability. And they have pumped huge money. In fact, initially in the 90s and 2000s, the Americans didn't pay much attention for development of supersonic and hypersonic technologies. Later they realized, when Russians have taken lead into this, they realized that we have to make investment, and they have made huge investment. And there are several reports which are talking about the products and already completed testing and under deployment. So these are the developments on the US side. Chinese, their focus is basically on the carrier killer capability, number one.
Yes.
And number two, when you talk about the glide, the hypersonic glide, then they are talking about the strategic, the nuclear weaponized glide vehicle. And Indian focus is mostly on the hypersonic missiles. So these are the differences.
Okay. General Saxena, sir, you were talking about the 7 hurdles that we have overcome.
Yes, sir.
But I need to understand one thing, that what they say that after overcoming the hurdles from 2020 to January this year, we have more or less reached a level of technology satisfaction, if I might like to say, that we are now likely to be able to produce these weapon systems. And there are other countries that are all in the race, whether you talk of Britain, you talk of France, everyone is considering this seriously. Where is it that we, being the 4th entrant to this space, we will be able to look up with pride and say, we are already there? Never mind, I mean, going back to our nuclear strategy, which is of minimum deterrence. So we are not in the numbers game. We are in the ability to have the technology to tell people, if you can hit us, so can we. And going back to the 1990s, when the Chinese had just a handful of missiles to reach the American continent, that was enough to worry the Americans that the Chinese have the capability. Today, of course, China has further enhanced and multiplied its capabilities. So, where are we looking at drawing the line, if you might be able to suggest?
Yes.
Because, these things can suck up funds which would be used better to battling existing threats that exist on the ground. There are those realities we have to contend, and the defense budget is a proof of that. And the second thing is, where is it that our own demonstrative vehicles will also add punch to platforms like the BrahMos 2, which is in the making?
I'll use the word being used by you many times in your book, dissuasive deterrence. We are trying to build, sir, dissuasive deterrence. Now, to say whether we have reached satisfactory standard, I won't put a word to it. I will first tell you that there are 7 challenges which are there right in front of us. 7 challenges in hypersonic weapons. What are those? First of all, to be able to withstand the thermal temperature. I was telling you, 2200 degrees centigrade. That is only one part. Second is communication and connectivity with the hypersonic vehicle. Because when a hypersonic vehicle goes at that speed, the electrons which are associated with the air molecules, they disassociate and form a plasma around. That plasma of charged particles prevents radio frequency waves to be communicated to them. Third, you rightly mentioned earlier, a nuclear weapon has a radius. It has to be positioned. The positioning and navigation is another very, very important thing. A challenge for us. Next is aerodynamics. Aerodynamics, so small maneuverability puts a tremendous aerodynamic load on the vehicle, not easy to control. Then comes the process of launch, making the hypersonic phenomena take place, which is called the wave rider. What is that? Wave rider phenomena takes place when a vehicle is projected at a fast speed. At certain points, the shock waves start acting as lifting surfaces, and the lift to drag ratio becomes so high that the vehicle separates and thereafter maneuvers on its own scramjet to a high speed. And another challenge. Biggest and the fastest challenge is, how does this monster which we have created talk to the battlefield, to the tanks, to the vehicles, to the command post, to others, that this is the target? How do you control the missile? How do you navigate? How do you battle management and control system? Now, these are the 7 challenges. Where have we reached? All right, we have crossed some, but long way to go. Nowhere near success.
Just a simple question here, sir, because we are running out of time. Do these vehicles provide us the capability of launching destructive bombs or nuclear warheads, etc., which will have area impact or pinpoint target impact?
They will have, the way it is hitting, it will be able to carry both conventional and nuclear. And the way our capability to position the strike will depend on where we place the nuclear or the specialist weapon there. And it is the characteristics of the weapon which will decide whether it will be a tactical nuclear hit or a large weapon. For a simple thing, a vehicle which is being tested on 27 January 23 has a payload capability of 300 to 400 kg. Now that sort of a thing can carry. Now you are saying, where are we? We are on our way. For a vehicle to be launched on 27 January, what did we achieve? Firstly, we achieved a booster which carries our hypersonic glide vehicle. Number 1. Number 2, the hypersonic phenomena did set in. Number 3, the vehicle did break from there. Yes, it did not fly. We have a target of 600 seconds flawed. It flew for less than 22 seconds, 22 point something.
Okay.
So we are arriving.
So we are getting there. We are getting there, and you seem to be very strongly optimistic, and you're building optimism in people like me also, who basically, I would like to throw up a question to all our friends who are watching, that is this going to be the new era of strategic deterrence based on hypersonic vehicles carrying nuclear warheads? So the nuclear era is now moving into another new era, or are we just using another force multiplier to hit our targets? But that's a question that some of you can think about, and maybe we'll try and give you answers next time. But until then, thank you very much for your brilliant insights, and thanks for watching. Until our next episode, goodbye.